All right. So what is vibe coding? Well, everybody's vibe coding now. So in theory, vibe coding is for throwaway weekend projects by the guy who invented the term vibe coding. But we're all professionals here. So of course we don't vibe code. We do prompt oriented development. So I think all development has, we're context engineers. We're not vibe coders. But I think let's just admit that we're all doing prompt engineering as our core workflow. So I think we know what all the problems are with vibe coding, but what are some of the less obvious problems, in my opinion, is that when you're just using natural language to express intent, modeling is implicit. Obviously, domain models exist. You tell it, make a model for this in Prisma, and now you have a source of truth about that in your Prisma schema, but I don't think that's first class. There's not really an ontological grounding. So you could say order one time and it means a purchase order, and other times it means the sort order or something like that, and there's some issues there. And then validation by domain experts, like what is the future of collaborative domain modeling or checking specifications when you're just fully sending it, knocking out a bunch of stuff. Like the productivity gains are great, but at a larger scale or with a team, I think you run into some problems. So full disclosure, I may have tricked you into listening to a talk about domain modeling and not vibe coding. Less fun. We got the DDD, Eric Evans' book here for anyone who's into that kind of thing. So inter-vibe modeling. What's some of the prior art out there? So when you literally just search vibe modeling, a lot of the stuff that comes up are things like Besser, this Besser thing, or Liam ERD, which is like a really nice looking ERD modeling tool. But I think when people say vibe anything, they just bolt a chat onto whatever their tool they already have. So that's what's happening here. So to me, I'm not really talking about bolting a chat onto an ERD tool, even though that could be cool. But one of the guys, I found an article about vibe modeling, and he did say something interesting. And he said, it's using an LLM trained for modeling rather than coding. But the interesting point was he said the model should generate deterministic code from those vibed models. So that's actually something that's really been on my mind and I think is really interesting. So, can we gain some determinism? I mean, I literally just today or yesterday, whatever, when I was vibe coding this presentation, messed something up, perverted it, and then tried to do it again, and the result was completely different, right? So as we know, it's not deterministic, and especially coming to things like your data model, that might matter. So for me, I think a key insight is vibe coding optimizes for output. Vibe modeling optimizes for shortest time to correct system would be a definition of vibe modeling. So there was the survey in 25 that came out that was, and they defined all these, I thought this was interesting, different types of vibe coding processes. Unconstrained automation, let's just say that's what most vibe coding is. Let it rip, right? It's unconstrained natural language. Iterative conversational collaboration sounds fancy. That just means you're talking back and forth. Planning driven, I think that's what has really become the core thing, right? With Claude Code adding first-class support for tasks. I think everyone's using PlanMDs. People are using tasks and making plans before doing things, which is great. And even test-driven or spec-driven, that's starting to happen in a meaningful way. So I'm going to buzz through some of these. I'll have my slides up later if anyone wants to see them. I have limited time. So just like what is domain modeling? I mean, getting a little out of order here, but event storming, domain storytelling, context mapping, these are all different ways to discover a domain when you're trying to model your domain. Just taking a quick segue here. So event storming is you just try to think about all the events that need to happen in your system. Do this in Miro or something. Domain storytelling is something I think is really interesting. It's kind of a pictographic language with its own dialect for describing domain stories at a high level. And just as an aside, they built this tool called Egon.io, and I think it leaves a little something to be desired if you kind of look at it. So moving on from the domain part, what's out there? I started to think, what about using more constrained language in my vibe coding? So instead of just pure natural language, what could I do to constrain my language to get better results or more deterministic results? So I started looking what's out there in terms of spec first and DSL. So one thing I found, has anybody seen this? 𝐸₂, it's Amazon's thing, 𝐸₂. Yeah, Dylan. And Dylan's in his stuff. Living spec, baby. You know, this is really interesting. When I first saw it, I thought, well, this just looks like what Cursor does now, because Claude makes these tasks for you and stuff. But if you're someone who's interested in spec-driven development, I actually think this is very worth checking out, because the couple of things they do, one is they're really big on property-based testing. So some form of verification, right? Not formal verification, but trying to get towards some practical verification of if your stuff is correct, as well as starting from specifications. 𝐸₂ uses something called ears, which is something I was not familiar with. When I think of specification, I think of BDD language, I think of Cucumber, Gherkin, you know, given, when, then. So they use something called ears, which actually came out of Rolls-Royce engine engineering, which I thought was kind of interesting. It's not something I'm super familiar with. So they use the ears dialect to write the requirements. And then they process those, as you can see, in real time. So kind of feed them in like tasks. So I think that's interesting. That's worth looking into if you're interested in that kind of thing. Another thing I found is there's a company called TypeFox wrote an article or paper about something they called SWAG, which is a semi-formal DSL that takes natural language and turns it into the semi-formal DSL. It's more of a specification DSL. I think it's interesting. It's structure first. This is what the DSL looks pretty much like objects. It is objects. In fact, they even use it to build UI components using this kind of language, which I don't think anybody really wants to write their UI like that, but it's interesting. Another thing I found that was really interesting is Microsoft's ODSL, the Office DSL. So this is the closest to what I've been thinking about, which I think is really interesting. They parse natural language into their DSL, which is then parsed into an AST that's verified, and then an execution layer. So if the LLM almost gets it right, it gets into the DSL, they can then verify it. So this is super interesting, I think, is they've been able to do really high quality generation, consistent deterministic generation using this process. So having the DSL as a piece in there. So I think my question is, you know, how do you make this more executable? How do you make it more visual? I love spec-driven development. How do we go up a level? And how do we get up the chain in abstraction in this paradigm, right? I think what I'm noticing is, and I would love for anyone in this audience to come to me after and be like, I don't even know what you're talking about, man. I've got this tool and it solves all these problems. That's great. What I'm seeing is a lot of, we're doubling down on code instead of trying to go up the abstraction stack from code. I'm seeing more code. In my consultancy practice, I see quality going down every day while output's going up. It's a real problem. So this is something that's very heavy on my mind every day, is I'm having senior engineers turn in slop because no one can possibly review all the code that these things generate now. So what's the engineering solution? Let's make agents, more robots that verify the code and review the code. That's why we just see a slew of 10 agentic code review tools come out this week from Linear and whoever else, right? But I'm just thinking about what are some other ways. And for me, it all starts with the domain model. So, you know, building an ontology, not just a model, what is a machine readable domain that actually has all the pieces of what matters in your platform application? So, you know, things like entities, relations, rules, states, right? This is an ontology. Vibe coding skips this. It's not first class. Again, please come up and tell me I'm wrong, but I know that I'm seeing a lot of, I love the use of context in markdown files and what people are doing with, you know, planning and specs inside of Claude Code. But I don't think I'm not seeing a lot of this, and I searched a lot. So the DSL approach also kind of leads to neurosymbolic programming, which is combining neural, you know, fuzzy with the symbolic part of the DSL, which is precise and verifiable. I think there's something really interesting about that. So I decided to use, for my experiments, domain storytelling as an entry point. Why domain storytelling? Well, just for example, instead of thinking about events, I think when you're in event storming, you're thinking about the events. That's kind of a very programming way to think about it. But when you're working with domain experts, it's a lot easier to talk about an actor does a thing and break it down from there. So I built a little grammar that looks kind of just like a BDD spec, right? It's like customer submits order, but there's some interesting things encoded in here. So it can determine actors, the difference between actors, work objects, which is what domain storytelling calls entities, properties, and containers. There's just a little light grammar set of grammar rules. You can use a dot notation to denote important properties on an object, things like that. And again, I like domain storytelling because it enforces some things. There's no bidirectional arrows. Everything's only moving in one direction, which makes things a lot easier for us. So what do I actually want to build here ultimately? Well, I want to take top-level domain stories. And of course, you could even take natural language and parse that into those domain stories, which is kind of our specification language. Break that into an AST, build out an extractor domain ontology. And my idea that is not implemented, but where I want to get to is actually extracting those specifications and expressing them as events that can be put into finite state machines. And then we can have some form of real verification where, in addition to just property-based testing, if you get things in a state machine, you can actually determine the reachability, safety, what states, things like that within reason. Obviously, there's some technical, physical challenges with that, but I think that's interesting. And then you kind of have a runtime. So verifying safety, liveness, and reachability, that's where I really want to get to. So focusing on behavior rather than structure or implementation, having some form of validation, some form of verification. Also, again, back to deterministic code generation, that's great, but also who checks that the model is right? Again, my experience with working with clients is most of the time you fail at capturing the correct specification, not at implementation, especially now with agentic coding, right? I'm pretty sure that agentic coding can implement basic algorithms. So DDD didn't become obsolete. It became essential. I'm going to beat the DDD drum here. Cool. So I'm going to do a little demo. So here's our little grammar parser. I hope this is big enough. The idea is I used a movie process since we're in a movie theater. But basically, as you type in each line of the DSL, I'm just going to put them all in. So here's our process, right? Moviegoer selects show, moviegoer tells preferred seats to cashier, cashier searches seating plan, cashier offers available seats, so on and so forth. Typical process. Now, as we know, a lot of things can be teased out and fall out of these types of specifications. But what I'm excited about from what is obviously like a very, very quick and early stage prototype is just how easy it was to deterministically extract the actors, the work objects, and to lay out the unidirectional flow of all the processes that are happening. I think if this was a lot prettier, it just becomes increasingly easy for a non-technical domain expert to verify that this is correct. And I think it's a happy medium. It doesn't have to be just for great big systems. I think this could work for big systems, but it's also interesting for any app you're building potentially. So some other ideas that are in here that are kind of interesting are, this is just a direct list. I think this could also be on a timeline. So here's a swim lane version. Again, apologies, this isn't very pretty, but what's interesting is it separated out swim lanes by actor and all the interactions and actions that take place against different objects over time. You could see this being something that could be played. Obviously, it needs a lot of UX love. Then it also generates all these state specifications. I don't think these are correct right now, but it just kind of shows the idea that we can generate events and how event sourcing or can map to events that can be consumed by finite state machines and can process these specs. And again, what I'm trying to get to here is if you can write high-level specifications, instead of just generating a bunch of code off of them, how much can we reduce the surface area to be something that's verifiable? Similarly, experimenting with, well, what does it look like to look at it from the journey of the object instead of the journey of the actor? Yeah, and that's pretty much it. Here's some other examples of like a to-do app or tic-tac-toe. What I did not do is have it try to build out the UI automatically. I think that the specification of what the swag specification does that, but what you end up with is specifying an interface in a very restrictive way. So I don't have a solution for that yet, but I'm actually not that worried about it. If there's one thing that I'm comfortable letting my LLM do, it's like write some React interface code. And I also think combined with a sensible standard library of components, that's a solvable problem too, of being able to have verified or battle tested components that can be put in to operate against this layer. There's probably also some kind of a need for an intermediate runtime, some kind of like runtime language that can talk to the FSM. And so that's the next steps on this experiment that I'm going to mess around with. So let me see here. So plain text domain stories, parsed AST with actors, verb, objects, and recipients, extracted entity list, relationship graph, building towards an ontology, open questions. Where does LLM come in? Obviously, it can be put at the front. Where does formality come in? I don't think we want to go to TLA plus for verification languages. Lean 4 is the new thing that's hot, that's being used to verify LLMs, but something more engineering forward, just like verifying maybe state spaces. And yeah, that's, I've got a bunch of resources in an appendix. If you have any, I'm out of time, but come and find me if any of this is interesting to you, and follow me or message me on Twitter at funkytech with a K.